Right, so this is our next session from Automania by me, Alejandro. And today we're going to be talking about heart valves, in particular, what can go wrong with heart valves. And this is area specialties, I think, for you, Claudia. So this basically, heart valves are tissue or leaflets in your valves or in your heart chambers, particularly in the ventricles, pulmonary arteries, and the aorta. And their main function is to provide unidirectional blood flow and to make sure that the blood travels from the atrium to the ventricles and then outward to the systemic circuits or the pulmonary circuits. There's 4 different types. The main ones are the mitral, aortic, tricuspid, and pulmonary, and they're found in the left atrium, right left ventricle, and then right atrium and right ventricle, respectively, as shown in the right way the diagram. There's also some support structures that hold these tissue together, and they're called the chordae tendineae, which are anchored by papillary muscles found in the ventricles, both left and right. And so when you look at these valves in particular, they're made of specific components, which can give them their biomechanical properties. Particularly collagen, elastin, and glycosaminoglycans, also known as GAGs. And so with all that together, you're able to achieve specific biomechanical properties as shown in the right images with shear stresses. You can compute that, which is probably what we'll do with ANSYS. So I will be teaching you guys how to do that. And then obviously it's subject to pulsatility and hemodynamics. So it has to interact with blood. It's a tissue that directly interfaces with the blood. So certain things that can go wrong with heart valves over time is that it wears down. But the main aspects of pathophysiology include stenosis and regurgitation. Those are the main categories. And you have these subcategories that can stem from these main categories, stenosis and regurgitation. Some of them include endocarditis, which is inflammation of the heart tissue because of bacterial infection. Connective tissue disorders like Mailer's syndrome or Mann-Fire syndrome. And then there's rheumatic disease and calcification. Most of the time, it's the aortic and mitral valve that are most affected because they are on the left side of the heart and they pump blood to the systemic circuit. But it can affect pretty much any valve in the heart. And here's some diagrams that shows what can happen when you have a stenotic valve or a prolapse valve which regurgitates. So current treatments include mechanical, bioprosthetic, and donor valves. Mechanical is a popular option because it uses these stents or these mechanical valves made of pyrolytic carbon. And so pyrolytic carbon is good particularly because it has anti-thrombogenic properties that provides minimal clots. Since blood interacts directly with the heart valves, you don't want it to clot onto your tissue because that would pretty much destroy the whole thing. Bioprosthetic heart valves, on the contrary, is tissue taken from either a porcine or a bovine organism. So in this case would be a pig or a cow. And they're good as well in terms of biomechanical properties. But the difference between mechanical and bioprosthetic heart valves is that if you take mechanical replacement, you usually have to take supplements in the form of warfarin or heparin to prevent anti-clotting or to prevent clotting or thrombolytics. And donor valves taken from another donor. So this is a nice brief intro video that you guys can watch on your own time. But in particular, one mechanical heart valve that's used popularly is the Abbott Regent mechanical heart valve. And there's many designs that follow this bi-leaflet design, which is a St. Jude design. So there's other mechanical heart valves prior to this, such as the ball and cage design or a single leaflet design. So the bi-leaflet design, as shown in the image to the top right here, allows passage of blood by the folding of 2 leaflets at top. And so these leaflets fold, the blood passes, and then it closes to prevent regurgitation. So let's get started. This is information on specs that's available online publicly. And let's go ahead and switch over to SolidWorks at this point. So this is how it looks like. And the first thing we're going to do is we're going to make a new part. File, new part. Okay, so now we're on a new part, and we're basically starting from scratch. This is an orientation of the top, front, and right planes. So we're going to get started on the top. We're going to show our top plane so we can draw on it, and we're going to sketch on it. So just to give some dimensions, we are using MGGS or MMGS, millimeter gram second. So that's our unit system. It's good to know that we're using MMGS. And we'll go ahead and put the required dimensions for this design. as provided to us in the PowerPoint was 21, the inner annulus, and the outer annulus is around 26.7. So the way it works is you have an inner annulus and you have an outer cuff. And the outer cuff is what gets anchored onto the native tissue. The inner annulus creates the opening for the heart valve. So we'll go ahead and say that this is 18 millimeters. And I think we are good there. Let's go ahead and put some reference geometry. And set these equal to each other. So we'll set them here equal on the parameters. We're going to add a relationship. So now these two lines are equal. And then once we're good, we just press D on our keyboard and we approve the sketch. Now this sketch is approved. So we have our top plane, and now we're going to draw a new geometry. So we're going to go ahead and draw a new plane. Let's make the front plane our reference. So now we have a new plane called plane 1, and it's a vertical, or it's an offset from one of our main planes, the front plane. So I'm going to sketch on this front plane offset, and we're going to draw some reference lines. And we'll draw an actual line. And we're going to add a dimension to this line. We'll make it 21 divided by 2, this long. Cool. And then what we'll do next is we'll create the profile for the annulus. If you look at it from the side, back to our PowerPoint, it kind of looks like this from the side. So now we're just going to add some dimensions to it. Let's fillet this. Let's move this in space. So we look back to our dimensions for it. It was 13.7 in height, total height. So we'll subtract 7.3. It's like 5. So that's our sketch dimension. That's how tall it is for this section. We'll set a vertical parameter here. So it's aligned. Make this vertical as well. And so by the end of it, you'll notice the sketches go from blue to black. So the difference is when the sketch is blue, it's underdefined. So if I can click and drag this spot in the sketch, I can pretty much move anything I want in this sketch. So it's just telling me if there's something missing in this sketch that would fully define it. And it's probably this radius here. So let me go ahead and add a dimension to this. All right, that's not the radius. But once you have a fully defined sketch, it will turn all black. So let's go ahead and mirror this. And mirror about this reference point. And let's finish the dimensions for the sketch to fully define it. And so now you have fully defined the sketch, you can control the parameters that you have within the sketch, which I think is easier. So now you can start getting more of that shape, like it is showing in the PowerPoint. So let's go ahead and go with this shape. That looks nice. All we just got to do then is just click D on our keyboard and approve it, or you can go up here to this icon and just approve it there. So now we have our side view and our sketch here. Let's go ahead and go back to this sketch. We're going to edit this again. And let me introduce you to the rollback feature on the family plane. So this here to your left is called a family plane or a family tree. It basically shows you the progression of your entire model from beginning to end. So our first item that we added was a sketch. We're going to go back and edit the sketch, or if you want, you can roll back the feature and suppress everything else until you only have the sketch. So I'm going to go back here, click edit sketch. I'm going to draw a line from here to here, and we're going to mirror this line without this reference. And now we're going to add conditions to it. Make it 8 millimeters long. And then we'll mirror this line without this reference. And you'll see why this is important later. So what we have so far, let's roll this. We have our base and we have our side sketch. Let's save it. We're going to save this as and we'll continue our features. So next you want to extrude boss base. Click your sketch on extrude boss base, and in this case it will be this one. And now you can select the contours you want to, or the regions you want to extrude. So if it's a contour, it's everything within a sketch. So for example, if I click on this line, it will choose the contour of everything within this line, which will be this region. As shown here, selected contours. So I'll go ahead and click your selection so that you can see. This would show the contour of everything within this circle. Delete this, and I want to select this contour. Now it's everything within that circle. But if I want to click a region, I need to click inside that region particularly. See? So these three regions make up the same contour of that circle. Okay. This is what I want to select right here. And I want to select it, extrude on both sides. And right now what I have is a cylinder looking thing. I go back to my sketch 2 and extrude that. So I want to unclick here, merge result, unclick that, and all you just got to do is extrude through all. Now you have these intersecting bodies. What you're going to do now, click S on your keyboard and do intersect. And you can intersect these bodies, these two bodies. The reason why you need to do two bodies is because you cannot create an intersection of just one body. So that's why you don't do merge features on the previous function. And then once that's good, you can click, and this will give you your final body. So this is the bulk of the work, just getting this outline, and you can do that pretty quick using intersect bodies. So next thing you want to do is you want to create the profile for actually the leaflets. Here's 1 second. Let me update something, because these leaflets are supposed to be aligned with this flat face. So what we can do to fix that is we'll go to our sketches, change the plane, edit sketch plane. Right now it's plane 1. This is the right plane. Yeah. Yep, no worries. We're going to end this feature. And then we select extrude through all. and this sketch is asking, where is my plane? So I need to give this sketch a new plane, edit sketch plane. In this case, we selected plane 1. Let's remove it. Yep. So there's just a warning and an error is that you can live with a warning. The way you would fix this is you just go back and you would redo that feature. So let's go ahead and do that. So here we are back to our feature, and we bring back the rollback feature. We delete the extrude, but we don't want to delete the intersect. And now we can go back and edit our sketch. Since this sketch is no longer, this particular section here is no longer available. So now I deleted that. That should be good now. Yes. There's just one part of the sketch that was changed. That affects the whole sketch. But now we can go back and do our extrude again. There we go. We'll repeat intersect. Let's get our new intersection. There we go. So this is supposed to look like once you're done. This will be this flat face where the leaflets will be mounted. And that's the shape. Cool. So what's next? You want to now mount those leaflets. And to mount those leaflets, let's hide this plane. Let's hide this plane. You want to have a sketch, and we'll do a sketch on a plane here between the two leaflets, between these two flat faces. Which plane would that be? It would be the right plane. So let's put the right plane to show, and let's hide our solid body. So now we're hiding our solid body, and let's sketch on our right plane. So let's put some reference lines. Set them equal. So we'll put an equal relationship. And then we can bring back our body. And we'll make it see-through. So now our body's see-through because it's only solid lines. And also make it hidden lines visible. So now what we'll do is we're going to draw the pivot. The way these bi-leaflets work is that they need to pivot on something. So there's some grooves within the mechanical heart valve that allows it to pivot. And if you remember, the pivot angle is 85 degrees, correct? 85 degrees. So what we'll do is we'll draw and put this here. Set this equal to 1 offset. And now add another center line vertically. .45 degree. So this is a reference line, and we'll be using this since we're going to draw a 5-degree angle offset from this reference line. Since it's 90 minus 585, so it's just 5. Cool. So now we'll draw another one. And we'll put 10 on this, and then 10 on this one. And let's make the that's straight. About this one. And that's also very cool. So now what we'll do is we can set all of these equal to each other. So now we're adding parameters and relationships to further constrain the model. So these lines are now their different sizes, and we want to set them equal to each other. So this is what we'll be doing now. Going through each one, setting equal to each other. So they're same length. So now we have the equal relationship. Now let's add an actual dimension. And we'll move this. So now I can have an idea of what it looks like. We'll go ahead and hide this body. Approve this, hide the body. It's just right now a couple of lines, but we're going to add an arc to it. And sketch. Let's add a 3-point arc to it. Another 3-point arc on this side. Add some dimensions. It's 2 radius. Make this 2 as well. Cool. So this is our pivot, and with this hinge, we're gonna be able to pivot our leaflets. Let's mirror this entire design about this axis. And then when we're good with that, let's just accept it. Bring back our body. And you can see right now our body. So now what you have to do is you already made your hinges for your pivot. Let's extrude them. Go features, extrude cut. In this case, since you have your flat face over here, you can just extrude blind. Go ahead. Try to just extrude surface. That's good. Extrude that and mirror the feature across the right plane. And let's check that it's there. It's there. Cool. So now we can hide our right plane for now. And actually what we'll do is we'll add a new plane. Add a new plane to the top plane on the opposite side. So flick offset. And for this top plane, what we'll do is let me introduce you to a feature called convert entities. We're going to sketch on it on this top plane. We're going to convert the shape of this body that we have here. Selecting this chain of lines. And we're going to project it onto our plane. You see it? So now what we'll do is we're going to offset entities with this chain that we have. And I'm going to reverse it. So there's the gap, which is okay. This is what we need. It's on top of this plane. Do a quick save and rebuild. This is what we have so far. Cool. We're going to hide this plane for now. And hide this sketch. And then what we're going to do is we want to focus on the leaflets itself. So we're going to hide our body, put it as wires with invisible lines. And we're going to sketch on our right plane. So we click our right plane and we click sketch. And we're not sketching over this sketch. We're sketching alongside it. All right. So here we go. We're going to draw our leaflet design. And we want our leaflet design to be parallel to the angles that we put on for the hinge. So we will just select these two lines to make them parallel to each other. And then make this line parallel to this line. Let's give them an offset to this, or a thickness. Let's make this 0.8 thick. And let's measure the difference in diameter between here and here. Yes. Okay. So right now it's limiting our sketch, if you see it, is this coincident constraint. So we'll go ahead and remove this, and this will allow us to drag our sketch. So we want to drag our sketch upward here, in between these two conditions. We'll put it centered between our hinges. We have one hinge here and our other hinge here. So what is dimensions here? 0.7, 0.07. So we're at 0.06. And this would be more or less 0.06. Yes. So now we know it's centered to our hinge. And coincident here by the wall of the mechanical valve. So what I'm going to do here is give some distance to this reference line, and now it's fully defined. There's a sketch number 5. Let's hide sketch number 3. Bring this back as a solid body. We'll bring our solid back like this, and we'll hide it. So now we're hiding our solid body. It's gone. And let's also, let's keep that there. And we'll bring back our sketch number 4 to show it. Features. Let's go ahead and extrude boss base this leaflet we made. Sketch number 5, extrude boss base. And we'll do the raw on both sides. And we'll go up here to our sketch number 4, and we'll extrude boss base that sketch through all. We don't particularly want the thin part of it, we just want the inside part of it. So that should give us this result. And right now you notice this has 2 solid bodies. We want to have 3 solid bodies. So probably here, edit feature, we need to correct for merge result. So unclick, merge result, and now it should be 3 solid bodies, because now we can do intersect. And then we have 2 solid bodies. Bring back our other one, and look at our leaflet design. It's right there. So where's our sketch? There's our sketch. Let's hide it. Let's hide the right plane. And do a quick save. So now we have our leaflet design. Let's go ahead and finish this mechanical valve up. So we know from the profile, from the specs given to us, that the entire valve is 13 0.7 is 13 millimeters tall. So from beginning to end is 13 millimeters tall. And that includes when the leaflets extend outward. So this leaflet right now is closed, and blood flow would go through these leaflets and it would fold like this downward. So here what we're going to do is we're going to create a new sketch, and we're going to extrude so we can get the shape, the final shape of the valve. Bring back our sketch 2. And which plane is that? Is plane number 1. So we're going to make a new sketch on plane number 1. And now let me introduce you to this feature called silhouette entities. Silhouette entities is going to take a body that you had and silhouette the entire body onto your plane. See what it just did there? It projected onto the outline of the silhouette. And this is useful because we're going to find the 13 millimeter mark, which is somewhere around here. Measure it. 13 millimeters, and from here to here, it was 4.7. Here to here. 8.3. So I want to be 7.3. All right. So this is good. Let's go ahead and close that. And now we have our side profile. And what we're going to do with this side profile is we're going to extrude cut into the body. We want to extrude cut this bottom profile that's excess, so we can achieve that 13 millimeter height requirement. So I'm going to extrude through all and remove that portion. And it's gone. So let's hide our sketch. Do a quick save. And now we can focus on making this look nice. So fillets. With fillets, the rule of thumb is that you want to begin from the highest fillets to the smallest fillets. So start with your bigger edges. And to do that, just go here under fillet and choose a fillet edges you want to do. So we have one. We fillet once, and then we'll fillet on the inside now. Another tip, if the fillet is actually not showing, that means you can't compute it. So for example, all these edges I'm clicking, I'm selecting them, but right now there's no fillet. You can't preview it because it won't be able to compute the fillet. You need to go here and change the fillet size for it to compute. See how it shows now? There's a preview for it because you can compute that fillet. How about this size? It wouldn't work. Can we go higher? 55? 55 works. How about 60? 60 doesn't work. So these are fillets that are constant radius. You can also do multi-radius fillets, which are a little bit more complicated, but it's still nice, and especially on biomedical applications where you need to have gradients of fillets for particular edges. But this is our fillet, not too shabby. And let's finish the fillet down here. So same principle applies. We'll go from bigger fillets to smaller. So it seems like the biggest thing we can do for a fillet is this 0.75 millimeters. We filleted this loop. Let's also fillet this loop here, these edges. And we'll handle this face now. We can fillet this face, or this edge here. Can we do a one fillet? All right. Do a quick save. And then what's next? You want to continue your fillets, so you want to continue it with your leaflets. So let's hide our mechanical valve and focus on this leaflet particularly. So one thing you want to avoid in your design in general is you want to avoid sharp corners. So let's fillet these corners here. Start with the bigger fillets first and then move downward to your smaller fillets. Now you can go ahead and focus on the smaller fillets for the face. There we go. So now I have our fillet done for both bodies. And you're like, well, that's only half a leaflet. I want both of them, right? So go back to mirror, choose our front plane, just mirror the body you want to mirror, and you're done. Most of the design's done there. So one thing you know is that there's no actual attachment between these bodies to the mechanical valve. So you probably need to extrude a body there so it can fit into the hinge. But for demonstration purposes, looks nice. So what's next? You want to add the cuff. And so the cuff is going to allow for the mechanical valve to anchor to the tissue. And I think the cuff goes around it. So what we'll do is we'll experiment with angles. Right now we have our main planes, the front and the right plane. Let's go ahead and add an axis between two planes, the front and the right plane. And with this axis, we can experiment with the angles of planes that we could add. So for example, once at this reference, it's a plane with the axis as a reference. And then for a second reference, I'll just use the front plane. And I can manipulate now the angle at which I want to have this plane. So I'm going to calculator. 360 divided by 36, 10. So 10 degrees. And we'll go even smaller, we'll do 5 degrees. And approve this plane. And so now we have a plane at 5 degrees offset from our right plane, from our front plane. And so the front plane, let's draw on it. Let's sketch on this front plane now. So let's do a quick save. Or just finish the sketch and then save. So we'll do a sketch from here to here, and then find a way to do it the shape of the cuff. And now we'll add some dimensions. Set this line equal to this line, so we don't have to measure it again. And then add an arc, a 3-point arc right here, and set it the constraints tangent. So you can have a full tangent 3-point arc. And I'll do even better. How about we make this 0.5 and connect this to this. So now we have a fully closed sketch. Cool. Let's go back to original sketch and just look from top. Show. And we'll see that this outer ring that we have on our sketch would be the cuff, the cuff circumference or the cuff diameter. So we have our inner annulus, and then we have our outer cuff. We want this sketch to be touching the outer cuff. So let's go ahead. And that looks good. It's more or less along the cuff threshold right there. Just a little bit above it. That's fine. We'll do the sketch. And then we want to repeat this sketch at the 5 degree offset. So let's hide our sketch and repeat this kind of semi-lunar shape at the 5 degree angle. So now we're sketching at the 5 degree angle that we made, the 5 degree plane angle, 5 degree angle plane. 0.5, and we'll set this equal to the other one. So we'll set an equal relationship. And then we'll add our tangent arc. Set the constraint here to tangent, and set it here to the tangent. So what do you have now? You have two arcs, or semi-lunar shapes, half moon, and let's do a loft. The loft is going to connect these features together, or these shapes together. And go to this one. So now I want to check when you do a loft for certain things. First of all, your sketch has the same number of dots, or in this case, the same number of connectors. So for example, if you do a triangle, you have 3 connectors, correct? So just three sides. And in this case, it would be an arc with 2 dots and a line, so 4 connectors. You might want to check your sketch to make sure that connectors are the same before you do a loft. So here we have 1, 2, 3, 4 connectors. That looks good there. And check our second sketch. How many connectors do we have here? We have 4. Let's set this constraint to this line. Coincidence. So now it's fully defined. Now the sketch is fully defined. Let's do our loft. All right. And since it's fully defined, the connectors are aligned. So before it was misaligned, but now you can see the connectors here. These would be the green dots. These connectors are aligned. And you can add or remove connectors if you wish, or you can even click and drag the connectors to a different portion of the sketch, like this one. See how the connectors are misaligned now? You would have one connector all the way over here and the other one on the other side of the sketch. Bring it back and that would align the connectors. Some parameters that you can use when doing lofts. You can have start and end constraints. And since our shape is small, we wanted to have rounded ends. This would be a nice way to make that start and end constraint. We would add a normal to profile vector. And it will round it. So for example, we have 0 normal to profile degree. It would be a straight shape or a straight line. As you add more degrees, you're getting more normal at the initial offset of this entire loft. So that'll be initiating constraints on this side, and the end constraint would be straight. Let's go ahead and add it. And there we have a loft. Let's mirror now this loft. We'll mirror the loft. Uncheck merge tangent faces. And we'll mirror this loft to the other side. All right. So see how we have our loft now? It was kind of like a cuff, almost. So what's more missing now is we're going to do circular pattern. Circular pattern is going to allow us to revolve all of this around 2, 4. Gotcha. Let me go ahead and edit this here. There we go. All right. So we had an extra body that came with our loft feature. So one way you can delete or keep bodies is by just pressing body delete/key. So back to our loft. Here we have our loft, and we want to revolve this around let's stick with this. Back to our loft. There we go. That should change it. Now we go check our mirror bodies. Good. So now let's go revolve this loft around. And we do that by using a circular pattern. We choose our direction that we want to revolve it. In this case, we want to make 32 equal instance spaces. And now it's more like a cuff. And so this cuff will be what's implanted onto the patient's heart tissue. Roll view. And so now the fun part begins, at least the part I enjoy the most, which is just adding colors. Let's collapse all of this. So to add colors, you just go here to render tools and you edit your appearance. So we know this is made of pyrolytic carbon, but chances are I don't think that's available in the database. If you want to edit your material, you can. You would go here to edit material, and it should create a database of everything available. Carbon. You have carbon steel, plain carbon steel, pyrolytic. Yeah, it's not available. So pyrolytic carbon is not available. What you would do is you would create a custom material, and you would fill in specific requirements for that material, such as Young's modulus, all the different requirements. But that will be for a different session. Let's go ahead and edit appearance. And this will make it appear as if it's glossy. Give it a nice finish. Do a save. All right. Go back to edit appearance. Plastic. High gloss. White gloss. So I think it was black for this body. We'll leave it black, and then for certain bodies, we'll do white. All right, so let's just go ahead and stick with that one, medium gloss, white medium gloss plastic. Let's go ahead and go to edit scene. The one I like to use the most is the reflective floor black. There we go. So we have our scene and we edit our appearance. Let's see how this would look like in a render studio. So we will click final render, or we will click preview window. So go ahead and let me know if you guys can see this. It asks if you want to add a camera. So we'll continue on without this for now. But let's say you want to add a certain angle within the shape besides the one you currently have. You can add a camera perspective. So we'll let this render, and we'll be back when it's done. So that was really quick, and I was impressed. Yes, it was. It usually takes at least 10 minutes. But this is how your render would look like at the end. I think what went is that the render quality might have been lower than usually. By the way, this is nice. This would be your final product. For most of senior design, you would get the render. Or let's say you want to make a design, quick design, you would render it. By the end of it, you want to save your render. So save image. And you decide, okay, where you want to save it to. Give it a nice name. Public V1 render. So that was pretty much the end of it. I hope you guys learned some things, and now you can go model a Regent mechanical heart valve. Some takeaways from this is that you now learn how to use intersecting for bodies. You learn how to apply new reference geometries such as planes, axes. You learn how to use lofts, and you learned how to do sketches like with arcs and with lines and stuff. You also learn how to add construction geometry, and more importantly, you learn how to add material properties. You learn how to edit materials and edit appearances and scenes, and you learn how to render. So I think that you'll be ready for your toolbox, take on new designs or new modeling projects.